In this video, we will introduce Android architecture. Android is a software stack for mobile devices that includes an operating system, middleware, and key applications. The mobile Android architecture looks a lot like the service-oriented architecture or SOA that's common in server development. Each activity can make an intent call to get something done without knowing exactly who will receive that intent. Developers usually don't care how a particular task gets performed, only that it's completed to their requirements. Applications. The Android platform is built like pretty much every other platform, as a stack with various layers running on top of each other, lower level layers providing services to upper level services. Apps run at the top layer. This includes apps that you write as a developer and those that Google and other Android developers do as well. Typically, apps running at this layer include one or more of 4 different types of components: activities, broadcast receivers, services, and content providers. Android provides a set of core applications: email client, SMS programmer, calendar, maps, browser, contacts, etc. All applications are written using the Java language. You will find all the Android applications at the top layer. You will write your application to be installed on this layer only. Application framework. The application framework layer provides many higher level services to applications in the form of Java classes. Application developers are allowed to make use of these services in their applications, enabling and simplifying the reuse of components. Developers have full access to the same framework APIs used by the core applications. Users are allowed to replace components. Some of the features are the view system, used to build an application including lists, grids, text boxes, buttons, and embedded web browser. Content provider, enabling applications to access data from other applications or to share their own data. A resource manager, which provides assets to non-code resources like localized strings, graphics, and layout files. A notification manager, which enables all applications to display customer alerts in the status bar. We also have an activity manager that manages the lifecycle of applications and provides a common navigation backstack. Libraries. Android platform has a set of libraries including an open source web browser engine, WebKit, well-known library libc, SQLite database, which is a useful repository for storage and sharing of application data. Libraries to play and record audio and video, SSL libraries responsible for internet security, etc. Android platform includes a set of C and C++ libraries used by components of the Android system exposed to developers through the Android application framework. Remember that the components of the application framework rely on a set of C and C++ libraries to perform their jobs. Developers interact with the following libraries by way of a framework APIs. FreeType, which is a library which supports bitmap and vector font rendering. libc, which is a library which is based on the BSD-derived implementation of the standard C system library, tuned for embedded Linux-based devices. libwebcore. This library offers a modern and fast web browser engine that powers the Android browser and an embeddable web view. It's based on WebKit and is also used by the Google Chrome and Apple Safari browsers. A media framework. These libraries, which are based on Packet Video's open core, support the playback and recording of many popular audio and video formats, as well as working with static images. Supported files include MPEG-4, H.264, MP3, AAC, etc. We also have OpenGL. These are 3D graphics libraries which provide an OpenGL implementation based on OpenGL ES 1.0 APIs. They use hardware 3D acceleration, or they included highly optimized 3D software rasterizer. Now we will stop and continue with the next lesson and take a look at further Android architecture. This concludes Android architecture part 1.